Welcome to Chemicals. So today I will discuss Sonogashira, Stille and Neghishi coupling. Basically these all follows the same mechanism. So I will draw the mechanism, and in the same mechanism I will show same time Sonogashira, Stille and Negishi. So let's see what happens. As I am discussing palladium catalyst reaction, it is also palladium catalyst reaction. So what we have, palladium 0 catalyst, and then we have an alkynyl halide X equal to suppose bromine or iodine. So it undergoes oxidative addition, palladium and here it is X. So all you know that it is oxidative addition. And then the important part, that is transmetallation. What we have, suppose an R group with another metal M dashed. Depending on this metal, it will be called Sonogashira, Stille and Negishi. That's the difference. So what is transmetallation? So what we have, palladium transmetallation. It will be transferred to this palladium metal. So R prime, and it will leave M prime and X. So this is the intermediate, and it undergoes reductive elimination. How does reduction? This one and this one, these two groups get reductively eliminated. So it will give our product, say R prime, and this is called reductive elimination, and regenerate the palladium 0. So how does it come to the Sonogashira, Stille and Negishi? Depending on this metal complex. So if we have an alkyne, say R triple bond H terminal alkyne in presence of copper salt, so it is called Sonogashira. Again, this was Sonogashira. Second thing, if we have a tin SN Me3, say alkynyl tin alkene, suppose this is R, so it will be called Stille. There I like to share one mnemonic, Stille tin, so you can easily remember Stille for tin. So there is no question of configuration, Sonogashira tin or copper, which one goes in with metal. So Stille tin, easy to remember. You can try your own mnemonic, whatever you like. But if we use RZN, say here, then this is called Neghishi coupling. So this is the three coupling reaction. One is Sonogashira, another is Stille, and another is Negishi. So difference are there, that it is a copper mediated alkynyl complex that undergo transmetallation. In this case a tin, and in this case a zinc. So I will take some example to show the three coupling reaction. First I will show one Sonogashira reaction. What I said that it's a copper mediated and alkynyl. So suppose I have substrate like this, iodine NH2. And you know this all these reactions are palladium mediated. So in presence of palladium, it undergoes oxidative addition as to all other reaction, iodine and NH2 as it is there. So suppose I have this alkyne Si Me3 triple bonded C and H. In presence of copper salt, it gives Si Me3 triple bonded C copper. So and I have shown already in the mechanism that it gets transmetallated. So this gives our palladium and NH2, and here the Si Me3. So it gets reductively eliminated to give the product Si Me3 and NH2. So this was an example of Sonogashira reaction. So let me take an example of Stille reaction. As I already shown that Stille tin, it's quite similar. So I will discuss it here. It's a quite interesting example as with other coupling reaction. Suppose we have OTF and this. So this is my substrate. And what happens that in presence of palladium, as in with the other same step, palladium, and this is as it is. And so now I have, as I said, it's a Stille example. So Sn Me3 and there it is Si Me3. So same with the other mechanism, it gives the, I am writing the product directly here. So it will give Si Me3. So you see that retention of the alkene geometry is conserved here. So this is basically the same with the Suzuki reaction, just this bond and this bond just coupled and the retention is followed. So this is an example of Stille. Let me write an interesting thing here. If this reaction is carried out in presence of salt is there, palladium PPS3, and if we do the carry out the reaction in presence of CO, THF says solvent, so there happens an interesting thing. The CO get inserted in this intermediate. So I am writing here what I said, that CO getting complexed with here. So palladium and CO and this. I have just inserted CO. So it will insert in this bond. So what we have, an acid system will be generated. C double bonded O palladium. Other things are as it is. So you see there is a acid COR. Then the same system is there. Suppose Sn Me3 and Si Me3. Then general follow the mechanism. Transmetallation followed by reductive elimination gives the corresponding product. So what will be the product? This is same. There is methyl and CO and again double bond as it is with the same configuration. So you see we get a ketone. This is just a little bit difference. So you should follow that what are the reactant presents are there. If there is carbon monoxide, you take care about that product is the ketone, and of course the alkene geometry is retained. So this is the difference. In presence of keto, what happened? Sorry, in presence of carbon monoxide, what happens? And absence of carbon monoxide, just simple Stille reaction. So this was I discussed Sonogashira Stille. Then come to Negishi. So I am going to do one example here. The example is pretty easy. What we have, a benzene with 3 chlorine substituted. So in presence of H5IO6 and H2SO4, we get the product iodinate, iodine and chlorine, and here also iodine and chlorine, here also iodine. So now there occurs and Si Me3 C triple bonded CH in presence of copper salt. So you know I have already told that this is an example of Sonogashira. I will come to the Negishi. So you know that what will happen. So there is a question of regioselectivity. Why? Because there is a carbon iodine bond and carbon chloride bond. So you may think which will undergo oxidative addition and go to the corresponding product. It can undergo oxidation product and give the product. Also chlorine gets undergo oxidative addition and give the corresponding product. So you have to keep in mind that which bond is weaker, carbon and iodine, then carbon and chlorine. So it will undergo first oxidative addition. That's why it will give the product where iodine was there. So what will be the SiMe3? All the iodines will be substituted, actually coupled to the alkynyl substituent. And here also SiMe3. And what we have here, chlorine, one chlorine and one chlorine is there. Now this time we have Negishi coupling. I will do the Negishi coupling. As I have already told that it is zinc mediated, zinc species. So suppose I have species like this, Zn(X). So I have taken an alkynyl and zinc. So in presence of palladium, of course. So same thing will happen. First undergo oxidative addition, then transmetallation and reductive elimination give the corresponding product. So I am writing the product directly. You can see the mechanism. It is basically the same thing, nothing else. So these things are as it is, SiMe3, and now there is no question of reduced selectivity. So all the chlorines will be carbon chlorine bonds will be coupled with this. So pH, and this all will be pH, and here also will be SiMe3 and SiMe3. So this part was actually the Negishi coupling. So I have discussed all the question of reduced selectivity and Sonogashira, Stille and Negishi coupling in presence of carbon monoxide. So basically that's the thing you can take care, and you can see the books, examples are there also. Thank you for watching.